Hi, everybody. Welcome to our very special webinar. We hope that this is one of many webinars that we will do as we introduce the latest and shiniest products that we are working on, and we are very excited to share them with you. So this is not the only time that we'll get together and talk about the wonderful things that digital asset is creating. And we want to hear from you as well. So today we have carved out, an hour and a half to have two of my favorite colleagues jump in and talk about our latest introduction to the Daml family, Canton and Daml 2.0. So we have, I am Steve Xiao. I am a developer advocate for the company. And we have David Richards, who is a principal product manager for Daml, and Curtis Rischuk, who is also a product manager, technical product manager from Canton. So they were deep into the woods to make sure that this becomes a reality, and they were the two best people I could find. So let's not waste any time. And David, shall we start with you, and we'll take it away. And when we are towards the end of the presentation, we will open it up for Q&A. And you've obviously found out that you cannot get on a video or speak, but we would love for you to put in your questions, and we have someone and myself will be parsing through the questions and getting to them as much as we can. And if we run out of time, we will find a way to get those answers to you. And if you do not want to ask them live, do go to our forum, and you can find it at digitalasset.com. /developers, and you'll find a way to our forum, and that's where you can post your questions, where we will get to them as well. So David, without further ado, all yours.
Thank you, Steve. Much appreciated. So as Steve said, my name is David Richards. I'm a product manager, principal product manager here at Digital Asset, and I'll be taking you through the first half of the presentation, focusing on Daml 2.0, the release that we had in March, some of the high-level views, so some of the high-level things that we've released. And then Curtis, my colleague, will take you through Canton and the details of that, the differences and impacts that's made on Daml. So, as I said, Daml 2.0 was released on the 2nd of March, so we're over a month after its release. And if you can't tell, we're very excited about it. It's been a landmark release for us and for our customers. And so, as I said, in this session, we'll go over the release, how Daml is improved by this 2.0 release, especially with regard to Canton. And as with all major and minor releases, we've included details in the release notes. So please go there. They've obviously been published since the 2nd of March. That will have a lot of the detail in there. You can see the URL on screen there, or you can alternatively go to the Digital Asset website and navigate to them using the developers blog in the top nav. So that will give you a lot of details. In this presentation, we'll cover the high level things, some of the things that you should care about as a developer that will impact you in using Daml 2.0. So let's take a look about what we learn about in this webinar. So first, we'll start with an overview of Daml 2.0 release. Canton, as I said, is the biggest improvement in this release, and we'll give you an overview of other updates that we've made, why we've made them, and how these changes are helping us achieve our overall goal and mission. Then we'll look at other changes, some in a little more detail and how they've impacted. And then we'll look at Canton. And as I said, my colleague Curtis will take you through Canton. The impact that it's made, what it is, why we're including it into Daml, and how it works. So that section will be great for those of you who, up to this point, aren't familiar with Canton, maybe haven't followed the story that Digital Asset's been on, the journey that we've been on over the past couple of years in developing this. And it should help you understand why we're including it into the product and how it improves Daml. As Steve said, feel free to ask questions as we go in the chat or other means, and they will then, I suppose, pull them through to us. So to really understand Daml 2.0, the release that we've made here, you need to understand a little bit about where Daml is now. So Daml's always been about creating multi-party applications. We build a smart contract platform, which provides our customers with the ability of writing smart contract smart contracts in lightning fast time, especially compared to older models. And we do this by focusing on the business logic and having confidence in the security and synchronicity of the data across organizations. So we've done this really with 4 main points. Data ownership, ensuring that data ownership and the rules surrounding that data are clear of who owns which data and which data is shared. Second of all, the interactions between parties when working with that data are strongly permissioned, and they're really at the core of the Daml language. And thirdly, data and processes are shared on a strict need-to-know basis. So for example, party B can't learn about party A's exclusive data and processes, and vice versa. And lastly, ensuring that it's fault tolerant. So parties can't falsify each other's records, either through fault or malicious behavior. And so really, all of this has given us a great foundation to build on for achieving our goal of the global economic network that we're aiming for, and has achieved and really given us the ability to release Daml 2.0 with confidence. So the Daml 1.0 smart contract framework, as I said, with direct integrations offered secure synchronizations and data integrity, but it didn't give us privacy or security against ledger operators. So customers could have confidence in the security and privacy of their data from an application level, and definitely in those using the applications and between parties collaborating on contracts. However, there was still a risk of data being seen by parties operating the ledger, or those who owned and operated the systems running that ledger. So for example, a cloud hosting company. In the case of a Postgres storage layer and a monolith architecture, that was the owner of the database, they could look in and see the data in the tables and whether they were involved in those transactions or not. In the case of our Hyperledger Fabric architecture, everyone on the same channel could see all of the transactions between any party, again, whether they were involved in those transactions or not. And so with the addition of Canton in Daml 2.0, it adds sophistication around the way that we integrate Daml with underlying ledgers. Using message encryption, Canton provides a model that extends to sub-transaction level and distributes data only to entitled stakeholders. And so Daml 2.0 ensures full transaction privacy without trading off security or consistency, and it enables full compliance with data regulations such as GDPR and HIPAA. And so I'll talk a little bit more about the driver differences here, but again, Curtis will go into this in a lot more detail later. So these additions in Daml 2.0 really opens the door to even stronger fault tolerance and prepares us for the future of Daml. Now, as we work towards the future of Daml, we'll be looking towards open business networks, continuing to lay the foundation, the technical foundation for the global economic network with fault tolerance and interoperability, providing you with full confidence in opening up your networks and contributing and benefiting from the global economic network. And so that takes me nicely to the company's overall objective here. And it is to create a global economic network of seamlessly connected businesses. So if you're not familiar with it, this is our company goal. And up until this point, many of our customers have built, critically important applications on Daml 1.0. However, we want to offer our customers the ability to participate in and build on top of the global economic network that has been the primary objective in building Canton and now including it into the product Daml 2.0. So this is and has been and will be the guiding theme for our product roadmap going forwards. And so the features in Daml 2.0 and in this release, in releases in the coming years, will allow customers to grow a network of applications which can grow together. And so in summary, this landmark release, the majority of what we're doing in Daml 2.0 release, for example, integrating Canton into the product, is nearing us to achieving this mission and objective. So now we've understood the goal, now we've understood where digital asset and Daml is going as a company, as a product. We'll look at the high-level changes in Daml 2.0, specifically relevant to you as the developer audience. So I'll talk about these in a bit more detail later, but this is a high-level overview, a sales slide, if you wish, about the most important changes in Daml 2.0. So as I said multiple times, first of all, on the left-hand side, firstly, Daml is including Canton into the product. And this is the biggest change in this release. So digital asset, we've been working on Canton for a number of years, and Daml will now ship with Canton participant and use the Canton protocol to communicate between the synchronization layer. Now, if that didn't make much sense to you in terms of the Canton participant, the Canton protocol, things like that, Curtis will clear all of that up later in the session. Secondly, we've made some changes in development tooling. So this is all geared towards developing applications for Canton. Canton's being used as the sandbox environment, so there's some changes in how you develop against it and configure the environment. Moving on to the third box here, the primary change here is how party IDs are generated. They're now dynamic instead of user-defined. And to help with that and help solve other problems, we've added the new functionality called user management, and it makes it easier to manage granting and revoking permissions for users. And finally, we've delivered a feature called participant metering, which allows users to understand and report the number of ledger events they're using on their systems. So with the adoption of Canton, we'll gain the benefit of drastically improving our drivers. So we're calling this new generation of drivers our Canton-enabled drivers. At a high level, that means they're not limited by or reliant on the capabilities of the underlying blockchain or database that customers choose to use with Daml. And so with these changes, Canton also becomes a ledger in and of its own right. And it's a privacy-enabled distributed ledger that's enhanced when deployed with complementary blockchains. And so Canton, as I said, will be covered by Curtis a little bit later, but I wanted to go into the high-level differences of these drivers, the first generation drivers and the Canton-enabled drivers. So in the first generation, we use the underlying blockchain or database as the primary storage. However, in Canton-enabled drivers, the underlying blockchain or database is used for messaging, sequencing, and topology only. So the primary storage of the transactions happens in the node of each participant, making sure that they only hold the information on the transactions for which they are involved. And this helps in solving that privacy issue that I spoke about at the start, where owners of the participants or owners of the domains can look in and see what's going on there. Here, it's only the operators of the participants, those who own the participants, who can see the details of those transactions, not of the domain owner. Also, in the first generation driver, Daml transactions were stored as plain data on the underlying blockchain or database. And if customers wanted cryptographic security, then Daml had to rely on the underlying blockchain system for that. With Canton-enabled drivers, Daml has Daml native cryptography, meaning that the message payloads are fully encrypted in the participant, giving full privacy independent of the driver. And then finally, in the first generation Daml drivers, there was tight integration between Daml and the underlying storage. And with Canton-enabled drivers, we've got a uniform protocol in what is known as the Canton protocol between drivers and participants, making them a lot less tightly integrated. And so all of this adds to Daml 2.0 being less dependent on the underlying blockchain or database. Now, moving on to the developer tooling and experience. So the first important change to the developer experience here is that the sandbox now uses the Canton ledger implementation. So for those of you who are maybe new to Daml or not familiar with it, the Daml sandbox is a component of the SDK, which allows developers to test their applications against a simulated ledger, so a simulated Daml ledger. So the sandbox is really a simple ledger implementation, which runs in-memory storage and is thrown away when the sandbox is closed down. And so the commands Daml start and Daml sandbox, for those who are a little more familiar with it, who have heard of that before, will launch a Canton test ledger. And having a Canton test ledger used when starting the sandbox is important, because in Daml 2.0, a Canton ledger is used in production. And therefore, we're keeping the production and development environments as similar as possible. And this should incentivize you guys, as developers, to adopt good practices when creating Daml applications, which should then make transitioning between development and production environments much, much smoother, as there's a lot less to change, or next to nothing, if you do it right, to change between development and production. Another major change with Canton ledgers is that party IDs are different to those used in Daml previously. So they have a user identifier, a user-defined hint at the start, with then a randomly generated hash at the end, and they're separated by two colons. And so this is to maintain uniqueness in a globally distributed network. And so the hash is randomly generated, and they're generated at the start of each sandbox, which means that party IDs can't be hard-coded into applications. So again, this makes development a little bit more difficult, but it aligns it much closer with development and production. And so, but also the new feature of user management, which we'll talk about in the next slide, also makes handling the dynamic generated party IDs much easier. And finally, Canton's static configuration is defined by HOCON, or what's also known as type-safe configuration files. So details on how Canton ledgers and domains can be configured is in documentation. We won't go into that in detail here, but the configuration files can be loaded when starting the sandbox, either in the CLI, or you can load that into the Daml YAML file. Okay, so now moving on to user management. So first, let's look at why we implemented this. So firstly, before this feature, users were mapped to Daml roles or Daml parties in each implementation, each customer's IAM service, which could potentially be difficult to do. Also, IAMs, like many systems that run in any organization, any enterprise, they don't often tend to be under control as the same people, yourselves, developers, who are maybe setting up the Daml participant nodes, as the people who own those IAM systems that you need to connect with. So it could make it difficult, or you have to talk to a number of people in your organization to get those roles and things set up. And roles such as read as and act as are often assigned in JSON web tokens, or what's known as JOT tokens, and they have a limit really as to how much data can be put into them, which also meant there was a limit as to how many read as or act as parties they could contain. And we saw an upper limit of around 100 parties per token. And some instances where they wanted users to be able to, or applications to read as and act as more parties, then that became a little problematic. So at a high level, user management allows customers to map parties and users to party rights on the Daml ledger. So, or inside of Daml. It's not held on the Daml ledger, it's held on the participant of each, on the participant layer of each participant. So you can do it inside of Daml instead of in the IAM. And so what really I expect you, developer, to use these newly created users for individuals or applications, and then map those to the parties that they can read as in Daml, such as end users, or maybe job titles, or team names, or company names, so that as people move around in your organization, then it's not tied to any individual, and people in certain organizations, for example, or applications there can have the same read as and act as rights. And so user management also allows you to assign more than 100 act as or read as parties, so more information that could be held in the JOT previously. And you can revoke and add rights much quicker from the console, rather than having to wait for a ticket to expire, for example. And so these user management, or in fact, user management adheres to the standard JWT, the JWT standard, and users are registered claims defined in the JWT standard to maximize IAM compatibility, and doesn't use custom claims like the previous JOT tokens. So older JOT tokens are still supported, and therefore participant operators controlling the IAM can still issue tokens on the old format, and they can continue to work with Daml as they did previously. However, if you wanted to use now the user management, then you would use the JWT standard token format, and that would be passed through to the user management feature. Okay, so what specifically can you do in user management? What are some of the rules and rights and obligations? So first, user management can be controlled from either the command line or from the JSON API. And you can obviously create and delete users, and you can also assign primary parties to that user, which means that they can act as and read as by default that primary party that they have. Then administrators of the participant can grant and revoke rights to users. So rights consist of one of three things, or all three. They can be made an administrator, so in turn that user can then go on and change the rights of others, and they can have an act as and read as party assigned to them. And also the maximum, I believe there's a maximum of around 1,000 act as and read as parties, so 10-fold increase from the previous method. And then we have commands where you can list users, which will give you the user ID and primary party for all parties on that participant. And so get authenticated user information and get specific user information as commands, and they will list the user ID and primary party for the authenticated user, the current user, or for the specified user request. So if you give it the user ID of a party, it will give you that information back for them. And as you'd expect, list authenticated user rights and list specific user rights will then give you the user rights of the authenticated user or for a specific user that you request. And then on the right-hand side of the page here, I've just given you an example. You can find a number of these in our documentation where you can list users. And then I've given you the full list on the bottom right. Again, you can find the rest of these in the user management section of the documentation. Okay, now on to the Navigator. So as a result, mainly of these party IDs and how they display, there's a few changes to the Navigator. Real simple. For those of you who aren't familiar with it, the Daml Navigator is a front-end application that you can use to connect to any Daml ledger, and you can use it to inspect and modify the ledger using a graphical interface. And so its primary use really is that we see you guys, Daml developers, using it to explore the flow and implementation of Daml models. And so, excuse me, when the Navigator loads, there will continue to be a drop down for login. However, by default, it will show you users instead of parties. So it previously showed you parties in by default in that drop down to login as. Once you log in as a user, you'll act as and read as the primary party of those users. And then users are set using the Daml script commands that you can choose to work with parties directly instead of users in the Navigator, defining them in the Daml YAML file. And so if you define users there, then if you don't define any users in Daml YAML, then it will switch to using parties by default. And as I said previously, how the party IDs in Canton are dynamically generated and they have a big long hash, it makes really party IDs impossible to guess or difficult and to remember, and definitely ugly to print and display. So to overcome that, we've put a simple feature into the Navigator. First, or a few simple features. Firstly, we'll try to auto-complete parties. So as you start typing the user-defined part of that ID, then the screenshot in the middle of the screen shows if you type in Bob there, then it will show you what the rest of the party ID is, so you can easily find it in the Navigator there. And then the final one is if you see a party ID, we will display the first so many characters, and then you can click on it to copy that to your copy board on your system. Now, one last section before I open up to any more questions. I just wanted to point out, with any new release of Daml, we always aim to maintain high stability and ensure backwards compatibility with previous versions. And so with Daml 2.0, even though it being a major release, we've aimed to maintain this mantra and to really reduce the migration and impact between Daml, 1.0 and 2.0. We've really kept the impact at a minimum in migrating from one version to the other. At a high level, we expect most projects to compile unchanged between versions from Daml 1.x to 2.0. And projects should also run unchanged, largely run unchanged on Daml 2.0 ledgers. Some other points worth making here is that we've removed for relevant to the developer experience, we've removed support for the Scala bindings and scenarios. We've also updated to Java 11, and we've removed old Daml versions. And so, and also I mentioned about the new feature called participant metering. And so part of Daml's charging model has always been based on the number of events on a ledger, and a feature for customers to be able to understand how many events is being passed through their ledger, and also send that information to DA has been added. Any information about that can be found in the documentation. And again, there's other things that I haven't gone into detail here, just small changes that have been made, as we do with any release, regardless of whether it's a minor or major release. And so again, I've put the link to the release notes here, where you can go find those on the Daml website, the digital asset website, and you can read those in any detail. Any questions, reach out to any of us after this call. Happy to answer questions there. So before I pass over to Curtis, and maybe while Curtis takes over the screen and shares his screen, any questions, Steve, or anyone else that we've had on the panel?
We have a lot of great questions, but I think we can hold them until after Curtis's section, because I think he may answer quite a few of them. Would that be good?
That's perfectly fine with me. Yeah.
Keep those questions coming, everyone. Thank you.
Okay, Dave, could you please stop sharing and I will take over?
Absolutely.
Okay. I'm assuming that everybody can see my screen. Thumbs up if anybody can see it. Okay, cool. So I'm the principal product manager for Canton, and so I'm obviously very happy to talk to you about Canton. I'd also like to thank you for taking the time out of your busy schedule to talk about this. But why Canton? Why do we need another distributed ledger? Why not just run Daml on the bare metal blockchain? What makes Canton special? We'll look into these questions. Just sort of going back to one of the first slides that David presented, we're going to go back to why do we need Daml anyway? And we talk about 4 dimensions to be able to use Daml to do the secure synchronization, right? Just a quick refresh. Firstly, Daml is concerned with data ownership. We want to make explicit who can see or change a piece of data while making sure that data is in the right place for those data owners. We don't want little pieces of data floating around. It's also strongly permissioned, right? If you have co-owned data between 2 organizations, you need to have processes to change and govern that data between those co-owners. And this is a core requirement for smart contracts. The third one is high privacy. And this means that data is shared only on a need to know basis. And this is needed for all enterprise applications. And the 4th dimension is where blockchain technology is very helpful because it enables the trustless, fault-tolerant, and multi-party environments. And most distributed ledger technologies offer you 3 out of 4 of these. But our claim is that no system offers the high privacy, which is the main differentiator for Canton. High privacy is Canton's superpower. And privacy, you don't really think about it that much until you have to. Right? It's sometimes overlooked on day one, but it quickly surfaces as a day 2 concern when the security team talks to you. And privacy is the basis for data security, and we want all our data to be secure. And we believe that privacy is absolutely critical to every enterprise application that is on distributed ledger technology. Now, that was pretty abstract. Let's make this a little more concrete. We'll use this example further on, so you just might want to take a peek at it. So we're going to make this concrete by using this example of a simple use case of delivery versus payment, DVP, which is an atomic swap of assets. We have Alice and we have Bob, and they want to do an atomic exchange where Alice pays Bob $100 for the promise of delivering a widget. Now, there are 2 parties that are involved here, aside from Alice and Bob. There's the bank, which is used to do the cash flow transaction, the cash exchange. And we have the factory, which is intended to do the exchange for that widget. Now, what we don't want is we don't want the bank or the factory to know about each other. But of course, Alice and Bob can see this. Our position is that none of the existing blockchains out there enable this level of privacy. Most blockchains talk about privacy, and they talk about the notion of a channel, a group, or a subnet, where you shard your system into smaller groups or components. But all the members within that group still see everything, so you don't get that needed privacy between parties in the transaction. So in our example, Alice, Bob, the bank, and the factory would see everything. You then have some distributed ledger technology systems that try to solve this transaction level privacy, where they drag asset histories with them to guarantee the ledger consistency. But you still don't get that privacy in the transaction. Everyone in the transaction can see all the steps in the transaction. And that is obviously unacceptable. Then we have the zero knowledge proofs. And quite simply, zero knowledge proofs are currently intractable for smart contracts. They're useful in practice, but really useful for simple token use cases on public chains. And so someone asked, what is Canton? Well, Canton enables Daml's full sub-transaction privacy without trading off security or consistency. And so we don't see any alternative in the DLT space for this sort of privacy. And that's why we're building Canton. And this sub-transaction privacy, it has some happy side effects. One of those side effects is scalability is possible, since the data is just not broadcasted everywhere. It also allows larger applications to be composed from smaller applications, forming larger transactions from sub-transactions. So what is Canton? Canton is a privacy-enabled, it's a distributed ledger and a ledger protocol that is enhanced and deployed with complementary blockchains. So we talk about Canton in two ways. We talk about it as a distributed ledger, and we talk about it as a ledger protocol. We'll see both of those. What we have here is the complete Daml 2.0 solution stack. It's a simplified view, but you can see the coarse-grained components. As you can see, Canton makes up most of the application backend of the Daml solution stack. It fully implements the Ledger API. And just a side note, in the pictures, the items in blue are those things that are part of the Daml solution stack. Canton does need the Daml DAR files for the application business logic. It also interfaces with the external authentication provider, which we'll discuss later. And the client requests are made using the Ledger API. In a typical distributed ledger technology, the users interact directly with the raw ledger. Canton complements this approach by adding participant nodes between the user and the ledger. You may notice that no additional trust is needed as long as each user retains control of their participant node. A helpful benefit of this approach is that the participant node eases the user's burden of managing the cryptographic information. This simplicity enables the user to interact with the DLT just like they would any other web application. In other words, Canton lowers the barrier to using DLT technology, which increases your overall market for any DLT application. And as we'll see next, both the participant and the raw ledger nodes are involved in the Canton protocol. A ledger node is perfectly suited to broadcasting the information amongst all the other ledger nodes to ensure they're all synchronized. That synchronization is important. But this strength is also a weakness, since the message envelope and data payload are visible everywhere. But the Canton protocol utilizes the ledger's node synchronization ability while providing data privacy of the payload. Let's start our overview at a very high level. Imagine we have a Canton deployment with several participant nodes. Each node has local storage, which is that node's view of the Daml ledger. The nodes are all connected through a synchronization layer, which acts as a total order guaranteed multicast system. So essentially, these nodes can broadcast messages in a totally ordered way so that each node receives the messages in the same order and then deterministically processes the messages in the same way. This slide adds a little more detail by introducing the Daml Ledger API, the Canton protocol, and the Canton domain. The participant node is the gateway into the Canton protocol. It exposes the Daml Ledger API, and participant nodes are where parties are hosted, so they enforce the business rules in the uploaded DAR files. The participant node connects into what we call the Canton domain, which includes the synchronization layer through standardized APIs we call the Canton protocol. You can think of the domain as a single Daml ledger. As part of the Canton domain, there are a couple of specialized nodes. The Canton topology manager node is about identity management. It also makes sure that there is a central place where nodes and parties can register. It guarantees that the participants have a consistent view of the entities and the parties, and it acts as a directory service for the certificates and keys too. The mediator node is about the aggregation of confirmations using cryptographic signatures. You can think of it as a transaction manager, and we'll discuss it more when we look at how the Canton protocol works. Drilling down a little bit more, we introduced one last type of node. We call it the sequencer node. Whoop. One of our guiding principles is that we want to make the Canton protocol pluggable and thereby extensible. And this is achieved using the specialized node that sits between every other node, and this special node is the sequencer node. A sequencer node is needed for any other node to connect into a Canton domain. So if we want to add another synchronization technology, we don't need to rewrite the mediator, the topology manager, etc. We only need to provide a sequencer that adapts to that technology. And what you see here is an example Canton deployment. You have a synchronization layer, which is a database or a blockchain. You have a bunch of sequencers that use that synchronization layer to collectively make a total order guaranteed multicast system. Then the participant node connects into that system, and the participant nodes store their data locally in their private contract store. But what about all that communication? Is it secure? Yes. All messages passed between all nodes are encrypted. When two nodes communicate with each other, they will use asymmetric cryptography to encrypt messages and sign message contents such that only the recipient can decrypt the content and verify the authenticity of the message or prove the origin of a certain message. In the next slide, we'll have a concrete example provided for this synchronization layer. A SQL domain architecture presented here uses a SQL database as a synchronization layer that was shown previously. David started the presentation by talking about Daml providing secure synchronization between parties. Well, here Canton is using a SQL database as a synchronization layer to complete a SQL domain that satisfies 3 of those 4 dimensions, namely, strongly permissioned data ownership with high privacy. For example, there's a full security between the participant nodes. Each node has the ability to validate and reject invalid transactions using cryptographic security. There's a high degree of security and privacy against the malicious SQL sequencer. The person operating the SQL domain can fake entries in the ledger. Proper configuration of the database provides some fault tolerance. And now these are all many of the properties that people care about. And this is a fairly easy deployment with the sequencer, mediator, and topology manager all bundled together to form a domain in a box to which all the participant nodes can connect. The trade-off with the SQL domain is that it is not completely trustless or fault tolerant. For example, you need to trust the operator of the SQL domain because the operator can do things like switch off the database or turn off some communication channels. If you want to get rid of those trade-offs, then use a blockchain. Here, the backend architecture subtly shifts by introducing blockchain nodes, each with its own blockchain sequencer. So for each blockchain node, there's an associated blockchain sequencer. Then each participant accesses the synchronization layer through their own entry point, which means you no longer have that single point of trust or failure. This increases the availability of the system. For today, the topology manager is still associated with one sequencer, but we plan on distributing it in a fault-tolerant way in the future. Now, blockchain performance could be quite low, which will, of course, limit the overall transaction throughput of the participants. Now, the blockchain sequencer, or the sequencer node introduces a clear separation between the synchronization layer and Canton because only the sequencer node is seen by the blockchain node. This means that the sequencer does not participate in the blockchain consensus algorithms. Smart contracts in Daml are not converted into native contracts in distributed ledgers. That is, there's no data conversion between Daml and the blockchains. Daml templates coded in Daml are not converted to chain code or Solidity bytecode in the DLT. And the parties allocated in participant nodes are represented in the participant node, not in the blockchain. Yeah, of course, these things may be relaxed in the future to support new use cases, but that's the current state of the affairs. Now, the result is that the golden source of truth is always in the participant node, while the distributed ledger technology, the synchronization there, keeps all the encrypted messages passing through the node. So there's a separation of concerns there. Now, I just want to give you a brief glimpse into how flexible the Canton approach is. You see two different kinds of synchronization technologies. You have blockchain or SQL. In a multi-organization deployment with many participant nodes, and you have two domains. You have the equity domain and the bond domain. Now, please notice that this third participant node has access to both domains simultaneously, so that an application running in this participant node can create atomic transactions, again, atomic transactions involving both the equity and the bond domain. I do want to mention that this multi-domain support is early access, but we will progress with it very quickly. So how does the Canton protocol work? We talked about Canton being a distributed ledger and being a protocol. We'll explain what I mean by protocol right now. Let's use the same example we talked about before, the atomic swap. So how does a transaction such as this one with multiple views for multiple entities actually work in the Canton ledger? Well, it always starts with one participant. In this case, Alice. She decides to submit the transaction to begin it. This begins with her submitting a ledger API call to her node, which we call a submitting node. She is a submitter of the transaction. Her node does a step we call interpreting the transaction, where it takes the command, the current state of the ledger, and from that executes the Daml code to figure out what the consequences of the resulting transaction are. The transaction is decomposed into different sub-transaction views for the different parties. Because there are explicit notions of data ownership and data readership, Alice's node figures out that the whole transaction should be visible to Alice and Bob. Only one payment sub-transaction is visible to the bank, and another sub-transaction should be visible to the factory for shipping the widget. Alice's node takes those individual sub-transaction views and encrypts them using the public keys of the targeted receiving nodes. The key information was retrieved from the domain's topology manager, which we don't show here. She encrypts the whole transaction, pardon me. She encrypts the whole transaction so that only Alice and Bob can read the whole transaction. She encrypts one leg so that only the bank can read it, and the other leg so only the factory can read it. Then she sends the whole bundle to the domain, which you remember is a guaranteed total order multicast. And each node will receive the sub-transactions they are responsible for. This means that the transaction and sub-transactions are sequenced to form a deterministic state of the system that is sent to all the nodes, and all the involved nodes pick up these encrypted messages effectively at the same time. Using their private keys, they decrypt their messages, they record the transaction as in flight, a pending transaction, and they validate their part of the transaction. Each individual party looks at their part of the transaction and asks, is this valid? So for example, the bank can ask the question, is it valid for Alice to transfer $100 to Bob? Does Alice have $100 in her account? If the answer is yes, then and the bank is fine with it, then their part of the transaction will be confirmed, and this check mark is that confirmation message being sent back to the domain. Each of these check marks represents confirmations being sent back to the domain. These confirmations make their way to the mediator, which is in the domain, and the mediator, as a transaction manager, aggregates those confirmations and broadcasts a commit transaction back to the individual nodes. The reason to do it this way is we honor that strict need-to-know basis for the data. So the factory and the bank are hidden from each other. The bank doesn't need to see the confirmation from the factory, and nor should the factory see the confirmation from the bank. The commit transaction goes back to the nodes, and since this is a totally ordered, guaranteed broadcast, each node sees the commit confirmation at exactly the same point in the order of events on this ledger. So there's now a consistent point in time in which every single node that is involved can say when that transaction is committed. And this is how we guarantee global consistency. The transaction is committed once that commit confirmation is received. And the privacy we've achieved is that each of the participant nodes has a plain view of their part of the transaction. At a global level of the ledger, there is only message envelopes with encrypted payloads. And so in that synchronization there, you may be able to see the target of the message, but you cannot see into the payload because the payload is encrypted based on the key of that target. So as long as you consider encrypted data to be private, there is full privacy. A similar synchronization mechanism is used to form domain topology transactions. If a new node or new party is added to the Canton domain, a topology transaction ensures that these changes are visible to all participant nodes at the same time. And this is needed for deterministic processing. The participant node will publish that local topology change to the topology manager. And that topology manager will broadcast the updates to all participants that are in the domain, including the participant that sent its local change. This broadcast involves the sequencer, so the change is seen by all nodes at the same time. So how can Canton deploy it? How can you deploy it? As you'll see, Canton can be flexibly deployed. For example, all the Canton parts, the participant node, the mediator, the topology manager, and the sequencer can run as a plugin within a single Canton application. Now, you might have noticed at this point, we've used this term node very loosely. We haven't defined it. And a node is not a bare metal server or virtual machine or container necessarily. Loosely defined, a node is a software object that is specified in a Canton configuration file. As you see in the picture, you can run as many nodes as you want in a single Canton application. And this Canton application is running on a single server. And that's one extreme. The other extreme is this deployment where each Canton node is running on its own Canton application and server. In general, it's a good security practice for each user or organization to be mapped to their own participant node. So obviously, there's a wide range of deployment options between these two extremes. Now, the choice of the deployment topology depends on where you are in the development lifecycle. For example, you can run a single memory-backed, single participant domain on your laptop as a development sandbox. You can incrementally add more detail and complexity. For example, here you can move to a more production-like environment where some nodes run in their own Canton application. You have a SQL domain that can be constructed, and you can use multiple application instances connected to their own participant node. And of course, you can build this out into a blockchain domain for validation or staging. And Canton can also be deployed in a highly available way. And high availability is a feature of the Enterprise Edition. So you can expand into high availability deployment for late stage testing or production. The participant and mediator nodes operate in an active passive mode. The sequencer nodes operate in an active mode. And just the remaining high availability configuration follows a similar pattern as shown here. For the sake of time, we'll move on to the next topic, but I did want to point out, I hope you noticed that these deployments can be built in a step-by-step fashion. And this avoids a big bang integration late in the life cycle. And I know we all hate big bang integrations. Canton and IAM. So IAM, as you know, stands for Identity and Access Management. This is all about authorization and authentication. This slide illustrates how IAM is configured. It shows that authorization in Canton requires an external vendor to perform that authorization. Okta or Auth0 are such vendors. As shown, the Daml application's login information is sent to the authorization server for the user to log in. The Daml application receives back an access token that it will send with requests to the participant node's gRPC server. And the participant node is configured in a different way for authorization because it needs to verify that access token. Each participant node is configured to retrieve a public key that is used to verify the access token sent on each gRPC API call. What is shown here is a configuration for an approach called JSON Web Key Set, JWKS. And this is the recommended approach because it supports the ability to easily cycle keys. Although not highlighted in this slide, each organization or participant node can even have its own IAM vendor. And David mentioned a new feature in Daml 2 called user management, which touches on these IAM operations. Now, this slide illustrates how IAM operates. As mentioned, first, the Daml application contacts the authorization server to get an access token called a JavaScript Web Token or JWT. As you see, the API request has a JWT token that the gRPC server receives. The gRPC server extracts that token, retrieves the public key from the authorization server, and validates the JWT token. Now, once validated, that user ID is mapped onto its associated parties and privileges. The party information is then passed on to the Daml interpreter. Now, there are two main points I'd like to emphasize. One is that a user is local to each participant node, and the Canton protocol only knows about parties. Now, setting up this IAM configuration is quite detailed, and I would refer you to the documentation. And at this point, we have finished and concluded the presentation. There was quite a lot of detail we went through, and I'm sure there's lots of questions. So who would like to take it away?
That would be me. Am I on video? Awesome. So we have a lot of great questions, and when I passed question number 12, and then 15, and then 20, I realized that we will run out of time, but that's okay. What we're going to do is we're going to try our best to address some of the questions that are more wide and in general, and then there will be ones that will need more time to dive into. And what we'll do is we'll either create a blog or we will somehow surface them in our forum. So if you have not joined our forum, it's discuss.daml.com. And we'll find a way to get those answers to you regardless. So let me start at the top. Now, the first question is, what is the difference between Daml 2.0 and Canton? Now, and why does it warrant its own name? So we may have covered some of that, but David or Curtis, do you want to quickly clarify that for folks who may have joined later?
I can give that a try. So Daml is a term that we use in different ways, and I just want to mention that. One way is we talk about Daml as the entire solution stack, right? I mentioned that in one of the slides. The other is we talk about Daml as the smart contract language, right? So it's a smart contract language. And Canton is the distributed ledger technology. So they can be a little bit confused if you talk about the solution stack, but really Daml is the smart contract language and Canton is the distributed ledger.
Fantastic. Awesome. So the next question we have is, and these questions will be repeated and re-answered in the blog as well. So I'm not gonna let anybody let any question slip. Next question. Daml 1.0 was open source, but I guess 2.0 is not. We have one of our engineers online. Stefano, do you want to take that question?
I can take it. So Daml 2.0 is open source.
Stefano, I think there's a...
Yeah, sorry. I'm on a Linux laptop and it thinks that my...
We'll have both Richard, David and Stefano clarify that question.
Yeah, sure. As mentioned by as an answer in the chat, Daml 2.0 is just as open source as Daml 1.0. Its development continues in the same repository. We have a separate repository for Canton. The link is on the chat. One thing that Curtis mentioned is that we also have an enterprise version that is not open source, of course, but the bulk of development still continues in the open source.
Yeah, just a couple comments on that. We are committed to open source. We believe in that. That's one of the ways we think we gain security, right? Is by having lots of eyes peer at it and point things out. Canton is open source. There is an enterprise version where we have features like data pruning, high performance, et cetera, but that's a small delta between the open source version of Canton. When you get the open source version of Canton, you get a fully operable protocol. So it will interoperate with the enterprise version as well. Next.
Wonderful. Stefano, while we have you, you answered a question about whether Canton is compatible with Daml script. Do you want to share the answer with everybody?
Yeah, so for those of you who are new to Daml script is the component that allows you to run Daml off ledger, not as exclusive as the non-ledger language. It's useful for initialization and testing. And Canton is you're able to use Daml script with Canton as much as you are with any other ledger API implementation.
Awesome. So next question. When is Daml Hub expected to catch up with Daml 2.0? When will we see Daml Hub have support for 2.0, in other words? And I think, David, you may be the man for this.
Yep, good question. So we are currently working on it. I can't give an exact date, but we hope, in the next couple of months, that Daml Hub will offer Daml 2.0 and Canton operations or Canton in as a ledger option. Outstanding.
Awesome. Now, next question. If the Canton encrypting or encryption, then if the Canton framework is encrypting, then the transaction message is distributed to all, but read by only the participants intended to participate in the transaction. Is my understanding correct? And I think Curtis answered that in his portion, which is the sub-transaction privacy, right, Curtis?
Correct. We only send data to those nodes that have parties that need to see or understand that data.
Awesome. Next question. Does the Canton protocol at all change the way certain contracts are divulged to parties as a result of an exercise consequence? Does the Canton protocol at all change the way contracts are divulged, which I presume is made observable to parties as a result of a exercise action, I guess?
Yeah, in Daml 1, I think David mentioned that data is broadcasted everywhere. You have the envelope and the payload as being one and the same thing. In in Canton, we distinguish between the envelope and the payload, and that they're both encrypted separately and only sent to the parties that need to know about it. In terms of the payload is only observable by those parties that need to see that payload. So yes, there's a difference between Daml 1 and Daml 2.
Wonderful. The next question I'm going to lump from various questions, and that is regarding the difference between Daml and Canton protocol and other platforms like Corda and Ethereum. Sort of the differences, the high-level differences. Who would like to take that?
I'll take that. So I mentioned that Canton's superpower is its high privacy, and that is the main differentiator that we have between Canton and everything else. The Corda, I think, uses the history of the asset. It brings it along. Ethereum and Fabric, they use the subgroup approach. And if you would refer back to that slide, you'd see that.
Awesome. This is more of an architectural question. Is there anything wrong with having the public party, I guess the public, as the only observer on every contract? Is there anything wrong with having the public party as the only observer on every contract? I presume this could be related to the idea that in Daml Hub there's a default public party, right? The public can see the contracts. But is that a clear question? So this, yeah, go ahead, David.
I cut out before the start of this question. Let me just confirm. Is there anything wrong with having the public party as the readers?
Yes, the readers, the observer on every contract.
I suppose that maps to your business requirement, right? Do you want that public party to be able to read, you know, all of those contracts, everything that goes through? If you do, then I personally don't see a problem with it. I think that's kind of what it was created for, right?
Awesome. This next question could be for Curtis. Is there support for SSI and credentials in Daml? Now, I presume that wasn't a typo, that you didn't intend to say SSO, single sign-on, and SSI meaning the self-sovereign identity connections, credentials.
Yeah, we use Auth0, so I don't really understand the question, I'll be honest. We might have to get back to them on that.
Okay. What about the user management differences between Daml 1 and Daml 2? How is that going to affect compatibility?
So if they're talking about the new feature of user management, it doesn't affect compatibility. You can continue using the same JOT tokens and the same custom format that you had previously, and you can still continue to authenticate using those old formats. If you want to use user management, then you can create a JOT in the new format with the user information in it.
Wonderful. Next question is about databases as opposed to using DLT. Why do we use SQL database? Can we not use CouchDB or any other DBs? Is Canton configurable with other databases if we wish to use other databases instead of SQL?
We test and validate against Postgres and Oracle. Postgres is available in the open source. Oracle is an enterprise class driver. There are lots of databases out there, and we just don't have the bandwidth to be able to use any database app. So in theory, there is no problem. In reality, there are probably subtle differences that the drivers would need to be changed or altered. So as demand for different databases is produced, we will respond accordingly. If you remember, the sequencer node is there. And what we need to do is just to tailor it for the particular underlying synchronization technologies. We've done that for a couple of databases. Extending it for a third or fourth is possible, but given all of the features and requests from our customers, we have to do this on a basis of priority. So, in theory, yes.
100%, yeah. Next question. What features of Daml 2.0 are not available on specific platforms now? For example, Fabric.
What features of Daml?
So what features of Daml 2.0 are not available on specific platforms now?
Yeah, not answering on a feature level, because I don't think there are features available on certain platforms and not on others. At the current state, we have a GA driver, so the Postgres and Oracle are GA, and then drivers for Besu and Fabric are currently beta, soon to be GA.
Fantastic. There's a question on how are we handling the private keys of each participant node? This is probably a question with the user management. How are we handling the private keys for each participant node?
Yeah, so the key, right now, the key handling is local to each node, and it is stored in the, it's stored on the participant node. We are looking at the requirements to be able to use a hardware or software-based key management integration. And so having the key stored off the node is something we are looking to do shortly.
Awesome. Here's another question. Is Canton customizable outside of basic configurations to fit a client environment? I guess this is a question of how configurable, how customizable is the Canton?
We have some very energetic, intelligent engineers, and so it is highly customizable. There's this tug of war that goes on between the product manager and the engineers. So the product manager says, make it as simple as possible, and the engineers think, yes, but we have to make it configurable for matching all of these other potential use cases. And so we've come up with a way that is fairly convenient in that we provide you smart defaults. And if you want to override those smart defaults, you can use an JSON configuration file.
Wonderful. Can we get an example of demo, or perhaps if we can point this person to a resource where we show how the participant metering feature actually works with multiple Canton domains? So where can we point folks to for more information or implementation of the participant metering feature?
So the documentation is the best place to go. I think if you're talking about multiple domains, so the participant metering just works at the participant level, right? So it is charged per event on the participant. So whether you're connected to multiple domains in with multi-domain in early access feature, or whether you're connected to one domain, the ledger metering is done on that individual participant.
Awesome. Here's a question I like. Well, I like all the questions. It's a good question. Are there limitations on the number of interconnected domains in Canton? And what is the impact on cross-domain messaging performance?
Yeah, so the multi-domain, just if people want to do this, the multi-domain feature is early access. And what we mean by early access is we're putting it out there for you to play with. But we do not recommend it go into production. We are obviously working towards GA, but we just want to make you aware of that. There is a in the documentation is a multi-domain workflow demo if you want to go and try that. And so that is something you may want to do. Steve, is there anything I missed in that question?
No, I think you got it.
Okay.
Yeah, I think you got it. Here's a good question. You said Daml language programmer, well, the developer can use Canton driver to natively encrypt data in the ledger. How is this different than non-Canton ledgers like Hyperledger? Isn't it possible for the programmer to encrypt the content of the block in Hyperledger if he or she wishes to do so? So this is a question about encryption and what is done natively and what is done outside of the Canton platform.
Yeah. So Daml as a smart contract language is compiled down to execute API calls against the Daml ledger. So the Daml ledger is a model. It's very sophisticated, very sophisticated. One of the things that I was impressed with when I started reading up about Daml is how a lot of the problems related to distributed applications or multi-organization applications were solved. So if we go back to that first slide about the 4 properties of secure synchronization, that is what we are aiming for. And if you, now, that runs on top of Canton. So now we have the full privacy. We did not have that before. So we implement all of the Daml ledger API. Now, what you're asking is, could something like the Daml ledger in all its sophistication and its properties be constructed manually by programmers? Anything is possible, right? But the question is, why would you want to do that? Because it's certainly error prone. You know, I have a joke where in the group I'm in, we have more PhDs than university departments have, and that's the truth, right? There are a lot of smart people that have spent 7 years building this and have had to rework it several times. You're leveraging all of that knowledge and expertise and testing, right? So I would say that's the reason.
In case that question is asking something maybe different, I think what they might be asking, sorry, my interpretation was, can't you just encrypt things with Ethereum, or can't the block be encrypted with Ethereum? And I think the difference is the transaction. So Curtis spoke a lot about sub-transaction privacy, and I believe in Ethereum, things are transacted at things are encrypted at a channel level. So anyone on that chat, anyone outside of that channel can't decrypt it, but anyone on the channel can encrypt it. So if you take Curtis's example of the bank, Alice, Bob, and the factory, all of those would be on the same channel, and therefore all would know about the same transaction. With Daml, the bank and the factory don't need to know about each other, and we don't let them know about each other because we encrypt things in a way that they can't decrypt it. Only the parties involved in that transaction can decrypt the things that they need to know about. I think that might be the difference.
Yeah,
they've got both sides of the question to answer that. Hopefully one hits it.
Thanks, David.
I love these questions. I don't know about you guys. They are really good questions. And if you don't want to post your questions publicly on the chat, feel free to hit us up on discuss.daml.com and just post your questions there. We'll get to them. If it's an architectural question or a technical question, just post it there. We'll get it answered. Here's another one. The reverse of fully private data is the recovery requirement for failed nodes. So again, the reverse of fully private data is the recovery of failed nodes, the recovery requirements of failed nodes. Is that a responsibility of Daml or the client apps? So this question,
could you redo that question? I'm trying to track it.
The reverse of fully private data is the recovery requirement for failed notes that fail, I presume, during the transaction. Is that a responsibility of Daml or client apps?
So at the participant node level, you have the ability to back up your databases, and the node itself exchanges snapshots of the active contracts. And so if a participant node fails, you can restore the database, start it back up, and it will talk to the other participant nodes in the domains, exchange snapshots of active contracts, and thereby bring itself up to the current state. So I think it's a node level built-in capability. I hope I answered the question.
I hope so too. Now, for the person who posted the question, if we did not hit the nail on the head, please reach out to me, and we will make sure that we get it clarified. Let me find another one that we can answer in the frame of time we have. Let's try this one. Is the concept of time now better with Canton? Does the confirmation to participants have the same ledger time which all participants could rely on? So I'll repeat that. Is the concept of time now better with Canton? I presume time as in time stamping, time. Does the confirmation to participants have the same ledger time which all participants can rely on?
So the second one, the answer is yes. And the first one is always challenging. The Daml ledger has a model of time, and Canton implements that model. And so you can program against that. So those are the best. I refer you to the Canton ledger causality and time description. And to the second part, the answer is yes.
Wonderful. There are a few more questions, and we're gonna need need to deep dive a little bit more and ask some clarifying questions to answer. And what I'll do is what we will do is to put that into that blog, or either we'll do a blog or post it somewhere in the forum, or make it into a video, or maybe we'll do all three. Let me see. Is there any more questions that we may have missed? I'm scrolling down. I think there's like 20 or 25 questions now. Would that be an example of how to use the system? Would that be an example of how to use the system? I presume we're talking about tutorials and ref apps and things like that. And that is probably a question for me. Yes, there will be. And there is already one. If you go to the documentation, in the section where we start to talk about Canton, there is a very simple section that walks you through implementing, adding the party to the participant nodes, adding the participant node to the domain, and so walk through that that tutorial. I think that's the best first stop to make if you are new to this. Let me just scroll through the questions. I think I got one just come in. Oh, is Okta available with Daml Hub?
Yeah, so I saw that. I wanted to know what available meant. I think, do we offer it with Daml Hub? No. Can you use it with Daml Hub? I need to check.
Got it. Okay, other than the questions that we need more time to elaborate on, I think we covered most of the key questions from the floor. I'm surprised we did it. I think that was like 15 questions or 20 questions right there. So Curtis, David, Stefano, is there any last concluding remarks or thoughts that you want to add? Any direction you want our audience to take a look at or pursue?
No, I mean, with Daml 2.0, I mentioned the release notes a number of times. Go take a look. You know, they'll have the details in. If you have any questions, reach out to any of us, and we'll be happy to help. Or post your question on the forum. That's probably the best way to to get an answer quickly. There's a lot of very active Daml developers on there who will answer your question.
Yep, and do answer them in the forums as well. And maybe this is a question for Stefano. Now, if I'm running a 1.81 project and I want to kick the tires for Daml 2.0, they can coexist, right? Is that controlled in the YAML file? How do I go about being able to do both on the same development environment?
Do you mean using? I mean, in general, what you would do is just transition your project to Daml 2 by updating your Daml YAML, and as mentioned by David before, the transition should be relatively smoothless. You will encounter maybe a few warnings or compilation errors and so on, but it should be relatively easy to fix those. There were a few deprecations that were there for a long time. So, but again, the upgrade should be relatively smooth. One thing that David mentioned is party identifiers. Those change a bit, so those will need to be handled. But apart from that, the transitions will be relatively smooth. In terms of coexisting, I'm not entirely sure whether this goes in the direction you wanted, but
no,
yeah.
You answered it. Okay. Now, you talked about deprecations, and one of the things that we highlighted in our release notes is that the handling of the party IDs. So we have a different way to generate these unique IDs now, and that if the current project had hard-coded the unique IDs into the Daml file, into the code, that may break, right? Do you want to add some color to that?
Yeah, sure. As mentioned, Canton produces these more complex party identifiers that is TLDR down to make sure that you can have parties that can exist at the global level. The impact on projects, as you mentioned, is that you cannot rely anymore on hard coding your party identifiers. This means that you can use the new user management service to query for parties that are associated with given user, and you can use those services to make sure that your application can work. This is probably going to be the more involved part which is going to be as you transition your project from Daml 1 to Daml 2. But again, the documentation should include examples on how to use this. And again, it just boils down to just simple best practices. Don't hard code your party names, but use the services in the Ledger API to build your application.
Good advice. Wonderful. So we've come to the end of the webinar. Again, feel free to post your questions and check out answers in our forums, and that is discuss.daml.com. And we would love to hear from you guys if this had been a useful session and if we should do it again, and what kind of topics you would like us to cover. We have a team across the entire continent, across all the continents, so we can cover any time zone. We're happy to dive into any topic. Now, if there is a conversation that's more business than technical, we're happy to point you in the right direction as well. So with that, I think we can wrap this up. And once again, thank you for joining us. David, Curtis, Stefano, thank you very much.
Thanks, Steve.
Take care all.
Thank you.
Bye-bye.